Hello, everyone. Welcome to Cracking the Code Interview 2.5, some lists. And the problem description is the same as Leetcode 2, add two numbers. So we'll just look at the interface of Leetcode. So you are given two non-empty linked lists representing two non-negative integers. And then we just, okay, the digits are stored in reverse order. And we need to add two numbers and return the sum as a linked list. You might assume the two numbers do not contain any leading zero except the zero itself. So here is one example: 2, 4, 3, 5, 6, 4, right? Okay, so one thing we can do, yeah. So as we observe this example, right? Okay, so we need to maintain two pointers. One starts at the first list, another starts at the head of the second list, and then we add them together. And so this will give us 7. And 4 plus 6 will give us 0. And 3 plus 4 will give us 8. So it is 8 because it has a carry, right? Carry is 1. The carry is 1. So with that being implied, we need to maintain a variable called carry, right? And the carry is initialized to be 0. But okay, so what can you tell about carry? Carry is equal to this number plus this number modulo no divided by 10, right? Divided by 10. And if it's greater than 1, if it's greater than 0, then it's going to be 1. Most likely is 1, right? Then we have a carry. And whenever we sum something up, whenever we, for example, sum 4 and 6 up, then we not just need to like sum these two elements up. Instead, we need to sum these two elements as well as a carry, right? It's just like the carry in this case is initialized to be 0 because 2 plus 5 does not exceed 10, right? But as we do 4 plus 6, then we have a carry of 1, and when we do 3 plus 4, we need to do 3 plus 4 plus the carry 1, which will give us 8, right? Okay, so it doesn't seem too hard for the general cases, but there were some edge cases. What if L1, list 1 is longer than list 2, right? If it's longer than these two, yeah, so that is pretty much like one edge case we need to consider, right? So it's pretty much like, right, we have a while loop, right? We have a while loop and two pointers. And let's just call this pointer start 1 and this pointer start 2, okay? So while start 1 and start 2 are valid, right? Are valid. And then we do the addition. But if the while loop terminates, when the while loop terminates, we have to do another check, such as is start 1 still valid, or is start 2 valid? Because we need to consider this edge case when list 1 is longer, right? If list 1 is longer, then that means our while loop will terminate prematurely, right? And when our while loop terminates, our start 1 is only at position 4 or position 5, right? It's still valid. So the next thing we need to do is to maintain is to like is simply to run through the rest of the list, and when like and yeah, don't forget the carry, right? And then just do the just do these just add carry into the rest of the list, right? Okay. And yes, and because we need to return a linked list, we might need to have a dummy node, which is called head, right? So yeah, let's just code it up. Yeah. Usually we have a dummy head, and it's initialized to be a null pointer. No. Okay. All right. So okay. and int carry, right? So carry is initialized to be 0. Okay, so while L1 and L2 are valid, then we need to do this. Okay, right. Hold on. We need to have a current node. And okay. All right, so after that, in sum, so first of all, we need to calculate the we need to calculate their sum, right? And sum is pretty much vel plus L2 vel plus carry, right? Don't forget about the carry. And then we have a list node. We call it insert to be sum, right? And yeah, also we need to recalculate the carry. So carry is simply sum divided by 10, right? And sum is sorry, sum can be this. Instead, it's this modulo 10, right? Because the max, because like it must be a digit. It can be like 2 digits. It can be 2 digits, right? It can be like 18. If it is 18, then it's 8, and we need to have a carry of we need to have a carry of oh yeah, sorry, not this, not this. We need to have a carry of 1, right? Okay, so then we are done with sum, and we can just do cur equals, okay, that cur equals insert, and L2 is, then we just move our L1 and L2 pointers, right? Okay, so okay, hold on. I think no, it's not cur equals it's not cur is insert. Instead, it's okay, so we add one dummy node, and okay, so we create a new node to insert, right? Then we need to do, cur cur next. Okay, so then we set cur next equals to we set cur next to be the new node, right? The new node to insert, and then we also increment cur by 1, right? That looks good. But to do next, cur is cur next, right? And okay, sum is this. Int sum is this. Um, head is okay. Dummy head, dummy next. Dummy next is oh yes, sorry. Dummy. Okay, and dummy next is cur, right? Okay, so as when we create a new element, then we can just do something like okay, so currently cur is like okay. Okay, then we set cur to be next. Then we just do dummy cur next to the 7, and cur is and we calculate new node. And cur next is Yep. That is all good. It's equal to dummy. And yes, this is all good. Okay, so that's how we traverse the linked list, right? Okay, so I have a dummy node, which is like a null pointer, like here in example one, like it should be here, right? And then we set our current node to be equal to be the dummy node. And then when we calculate the first node to insert, which is 7, then we just set cur next, which is also dummy next, because cur and dummy are equal, right? So then I said cur next is insert. That connects dummy to the first node, right? And then I move cur to the new element I just insert. And then when I calculate another element, which is in this case 0, right? Then I just do cur next is 0, right? 7 next is 0. And then I move my cur to 0. And in the end, I can just return dummy dot next, right? So that's the overall strategy. Okay, so if list 1 or and the list 2 doesn't have the same length, right? That means either list 1 or list 2 are either list 1 or list 2 is valid, right? Okay, so if list 1 is valid, what's going to happen? Right, what's going to happen? Then list node insert. It's pretty much the same, right? Then list node insert is and next is insert, and cur is cur next, right? Yeah, we just need to get rid of this. And in the end, right, cur next is just a null pointer because we've already reached the end, and we we should return dummy next, right? There is a possibility that we need to delete that dummy node. Oh, interesting. So what is this? What is this case? Okay, L1 value plus oh, there is actually another edge case to consider. Yeah, but it's not directly associated with this one. Yeah, what if carry is not 0 in the end, right? What if carry is let's say like carry is still like carry is 1, right? What if carry is 1? So if carry is 1 after all this, so if carry is 1, then cur next is new place node 1, right? And cur is right. Um, so that is. Or do you think I should? I don't need this. It's the same, right? Okay, now it has a 1. Interesting. How does that work? It's getting very interesting, huh? So, okay. So L2 is not valid, and L1 is still valid. It's still a valid pointer, right? So sum is L1 value. Okay, L1 plus. Okay, this. And L1 value plus carry. divided by 10. This is all good. And then we have a new node to insert, right? Which is 0 in this case. And yeah, what's the problem here? Why I'm missing two zeros? Why am I missing two zeros? Zero, zero, one. Yeah, it's very interesting. This is very interesting. Um, oh no. Haha. Yep, 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 yep. I didn't even increment next. Come on. I didn't even increment, didn't even move L1 and L2. Sorry about this typo. It's very, yeah, it's very stupid. Sorry about that. And also, it shouldn't be a uh, if statement. Instead, it should be a while statement, while loop. Okay, let's see. Yep, this give us the correct answer, and let's submit and save. Yep. All right. So, well, this is amazing, and yeah, I love this video a lot. It's been my favorite video making experience so far. So, that's it for this program. Hope you enjoy it. And yeah, let me try it. Will this also give me a good answer? Yeah, it's the same, I suppose, huh? Yep. Oh, wow, interesting. Yeah, it's funny that like it's pretty much the same. I just like I just made cur next null pointer, but I can even see a huge improvement on runtime and memory. Yeah, I mean sometimes Leetcode is inconsistent like this, which is not very good. And well, that's it. Hope you enjoyed this video and have a good night. I'll call this today. Bye.